Imagine every time you pushed code, it went straight to a live plane mid-flight. There would be no checks and no tests, just vibes. Some days it would work, and on other days the engines would stall. That is what shipping without a proper CI/CD pipeline really feels like. Now imagine the opposite. Every change rides a conveyor belt that carries it through automated checks and fast tests, as well as security scans and controlled deployments. When something breaks, it causes alarms to fire and the line pauses. The fix moves through the very same belt. That's called continuous integration and continuous delivery. CI/CD. Imagine your CI/CD set up to be a factory floor. The version control system is your warehouse and source of truth, whilst the pipeline is the conveyor belt that moves changes forward. In that pipeline, you have automated tests and checks. These act as quality gates along the belt. You also have monitoring and metrics that are dashboards hanging above the line showing the health. Finally, production is the shipping dock where finished products finally leave. So you can see if anything skips the line, quality becomes a matter of luck rather than design. So the idea is we start with a simple rule. Nothing ships unless it rides the conveyor belt. So before we start the discussion about pipelines, we need to talk about Git. Version control is the warehouse where every change is tracked. Each commit is a labeled box stored on a shelf. You have branching strategies such as Git flow or trunk-based development that are simple ways to manage lanes inside that warehouse. Feature branches are side aisles where you assemble new pieces in isolation, while pull requests act as inspection points before the box enters the main belt. Good practice here is straightforward. Everyone commits early and often, and every change is tied to an issue or task, so that nothing is anonymous. This means the pipeline is triggered by changes in version control rather than by magic scripts on a laptop. This is GitOps. If it is not in Git, then in practical terms, it simply doesn't exist. Now you have version control with Git. What's the next problem? So imagine you have loads of engineers and they're all developing on their own machine. Some might say, well, it works fine on my machine. This is what happens when every stage of the pipeline cooks in a slightly different kitchen. In a healthy CI/CD pipeline, build environments are consistent from start to finish. The same tools and the same dependency versions, as well as the same configuration, are used for build, test, and deploy. You can achieve this with container images, with infrastructure as code, and with pinned versions of your toolchain. I've used the idea of a kitchen in a previous video to help build a mental model for DevOps. In this case, we can use it in CI/CD. So imagine every chef walks into the same layout with the same equipment and the same ingredients. That way, when something burns, you know that the problem lies with the recipe rather than with the oven. Automated tests are the quality gates on your conveyor belt. However, if each gate takes 10 minutes to open, everyone ends up staring at a red light. Prioritizing fast tests means you run the cheapest and quickest checks first. You start with static analysis and unit tests, then move on to integration tests, and only afterwards run the slower end-to-end flows. This is your test pyramid in motion. Developers push code and the pipeline runs in seconds or receive a clear yes or no. The goal is short feedback loops. If a two-line change breaks a unit test, you want to hear about it while the change is still fresh in your mind, rather than 3 hours later when you're already deep into a different problem. Historically, security lived at the very end of the process. A security team would carry out a large review once or twice a year and hand back a long report of issues. In a CI/CD world, that approach no longer scales. Instead, you bake security and compliance into the pipeline itself. You treat security checks as gates on the belt. Static application security testing scans the code as it passes by, and dependency scanners look for known vulnerabilities in libraries, whilst compliance checks validate that you are not accidentally leaking secrets or violating policies. Think of it like an airport, right? You don't fly first and then go through security later. The security gates form part of the journey. In the same way, no build should make it to production without passing basic automated security and compliance gates along the way. Remember, your CI/CD pipeline is a product, and products need metrics. To improve the assembly line, you first need to see it clearly. That means instrumenting your pipeline with timings and counters, together with alerts that fire when thresholds are breached. You track build times, and you also track how long different test suites take. You track deployment frequency, and you track how often builds fail, as well as how quickly you fix them. Some classic indicators, for example, build time, test coverage and failure rate, deployment frequency, and mean time to recovery, or MTTR. Like I mentioned previously, imagine the dashboard above the conveyor belt. If a station becomes a bottleneck, the lights turn amber. If a deployment fails, an alarm goes off, and the team knows exactly where to look. A beautifully designed pipeline is worthless if half the team quietly ships around it. There needs to be clear rules. All changes to production must go through the CI/CD pipeline. There's no manual edits on the server and no secret scripts on someone's laptop. The enforcement of this rule is both cultural and technical. Technically, you can lock down production so that deployments are only allowed from the pipeline service account. Culturally, you make the pipeline the path of least resistance. It should be easier to open a pull request than to hack something directly on a box. The factory analogy here is simple. There are no side doors to the shipping dock. Every product goes through the belt, and that gives you consistency, traceability, and a clear history of what changed and when. So, when you put all of this together, CI/CD stops being a mystery and starts feeling like a calm routine. Git provides a single source of truth and a natural trigger for the line, while consistent build environments ensure that behavior is predictable from deployment all the way through to production. Fast tests then give you tight feedback loops, and at the same time, security and compliance checks run early and often. And metrics turn the pipeline into something that you can monitor and steadily improve. Finally, enforcing pipeline usage keeps everything on the belt instead of allowing side paths. This leads to the result of fewer surprises, faster recovery when things break, and a team that is less afraid to ship. Hopefully that explains CI/CD to you all in a very nice and simple way. If you liked the video, please subscribe.